Hey guys, Mr. Gagnon here. I'm going to get into a new topic called magnetism, and you've already watched the first video. That's a Khan Academy video about how they came up with the name for magnetism, and they describe what a magnet is. So we're going to get into something called magnetic fields. So I'm going to get that for you guys in a set of notes here. So magnetic fields. Okay, so magnetic fields can be described with a picture. So what I'll do is let's draw a picture of a magnet. Okay, and we'll call this the North Pole. We'll call this the South Pole. And what's nice about magnetic fields is that you can actually see them. If I were to sprinkle some iron filings around here, you'd be able to see the magnetic field lines. So there are a lot of pictures on that all over the internet. So the one thing I want to talk to you about is that we arbitrarily decided which way the magnetic field would flow, and we said that the magnetic field lines are defined as leaving the north pole of the magnet and then entering the south pole of the magnet. The more lines you draw, the stronger the field is. So if I were to draw a picture here, okay, here's my north pole. Okay, and I'll draw some field lines that go from the north to the south. So they go this way. So again, north to the south. And again, the more lines I draw, the stronger the magnetic field. Okay, so these are coming out here. So just from this slide, you're going to understand that we go from north to south with the magnetic field. So what I've done is I've drawn two bar magnets, and I've put the north poles facing each other. So the field that would be produced would be an interesting field. So if we say it flows from north to south. So but these fields here, okay, they don't touch each other, so that goes like this and like this. Okay, and again, these guys don't like to touch each other, so going like this. So you got a field that kind of looks as if it's like kind of going away. Okay, and this one here going away. Okay, so you've got this kind of like this weird shape. Now obviously there are some more coming out and back in, coming out and back in, okay, and then out and back in, out and back in. So notice how we have a space here. Okay, here's our space, and these fields aren't touching each other. They're just saying, whoa, wait a minute, I'm backing off of you, and then whoa, wait a minute, I'm backing off of you. Okay, so they don't touch. So now, if I get a magnet and I turn it around where the South Pole is facing the North Pole, a different thing happens. Okay, so what happens is the North is attracted to the South, so that magnetic field will look like this. You'll have a field lines going from north to south, north to south, north to south. And then some of these north to south field lines will go from north to this south, from north to this south. So it looks kind of like a weird little image there. Okay, so that basically shows you what the magnetic fields actually would physically look like. So what I'll leave you with today with the magnetic fields is the units for magnetic fields. So a magnetic field is denoted by the symbol B. Okay, this has a magnitude and a direction, so it is a vector. The unit of B is called the Tesla. Okay, T. And the Tesla is a very large unit, so sometimes we use it something called a Gauss, okay, which is G, and 1 Gauss is equal to 1 times 10 to the negative 4th Teslas. To gain perspective, the magnetic field of the Earth is about 0.5 Teslas. Okay, we're going to leave it off there, and we'll give you a short quiz on this little section. Okay, basically it's going to ask you to draw some pictures and what certain magnetic fields look like with magnets that are next to each other or single magnets. Okay.